morning, students. In our previous class, we discussed about the definition of ionization potential or ionization energy. We just discussed about the definition only, and there we should take care about the keywords which are present in that ionization potential. And what was the definition? The minimum amount of energy required to remove the most loosely bound electron from an isolated gaseous atom in its ground state is known as ionization potential or ionization energy. Atomic radius vary across a period and down a group. How it vary? Atomic radius decrease across a period from left to right and increase down a group. Like that, ionization potential increase across a period from left to right. If we consider any period from left to right, it will increase, and down a group it will decrease. Left to right it will increase, and down a group it will decrease. What is the cause behind it? As soon as we go from left to right, atomic radius decrease. Atomic radius decrease means the attraction in between the nucleus and outermost cell electron will be increased, and higher amount of energy is required to remove that electron. As soon as we go left to right, atomic radius decrease. That means effective nuclear charge increase. As a result, the attraction in between nucleus and outermost cell electron will be increased. As a result, higher amount of energy is required to remove that electron. For that, ionization potential will increase from left to right. But when we go down a group, atomic radius increase. That means the attraction in between nucleus and outermost cell electron will also decrease, and lower amount of energy is required to remove that electron. As a result, ionization potential or ionization energy will decrease down a group. Now, if in the valence shell there only one electron is present, then no problem. But if we consider in case of aluminium, where the atomic number is 13, that means the electronic configuration will be 2, 8, 3. In first cell, if this is the nucleus, this is the center of the nucleus. If this is first cell, here the number of electron 2. In second cell, the number of electron 8, and in the third one, the number of electron is 3. Number of electron is 3. Here what we see, at first we may remove this electron, or we may remove this electron, or we may remove this electron. for a single time we are unable to remove all these 3 electrons, we should remove these electrons one after another. Now, if we remove this electron first, then the amount of energy which is required, that should be lower when we remove the second electron, and that is lower when we will remove the third electron. That means third ionization potential always greater than second ionization potential, and second ionization potential is greater than first ionization potential. That means third IP is greater than second IP is greater than first IP. Always you should remember this. What is the cause behind it? When we will remove this electron, then the number of proton is 13, whereas the number of electron is 12. After removing one electron, the number of proton is 13, but the number of electron is 12. That means the attraction will be higher. That means the attraction will be higher. For that, when we try to remove it, then higher amount of energy is required, because the effective nuclear charge is increased, attraction will be increased, and higher amount of energy is required to remove this electron. When we remove these 2 electrons, then the number of proton present in the nucleus is 13, whereas the number of electron present is 11. For that, effective nuclear charge is again increased and higher amount of energy is required to remove these electrons. So from here we come to a conclusion that third ionization potential is greater than second ionization potential is greater than first ionization potential. Next is our electron affinity. Electron affinity. In case of ionization potential, what we see that if we remove electron, if we want to remove electron from the outermost orbit, then we should give energy. Energy is absorbed. Energy is absorbed. What is electron affinity? In case of any atom, if it take electron in its outermost shell, then it should release some amount of energy. In case of ionization potential, electron is come out, for that it absorb energy. And in case of electron affinity, when it will take electron in its outermost shell, then it should release some amount of energy. Then what will be the definition of electron affinity? The amount of energy released, when an atom takes electron in its outermost shell, and convert itself into an uni-negative ion, that amount of energy is known as our electron affinity. The amount of energy released, when an atom takes electron in its outermost shell and convert itself into an uninegative ion is known as electron affinity. The amount of energy released when an atom takes electron in its outermost shell and convert itself into an uninegative ion is known as electron affinity. Here the amount of energy is released. Our electron affinity. If we consider electron affinity like ionization potential, it also increases across a period from left to right and decrease down a group. Like ionization potential, electron affinity also increase across a period from left to right and decrease down a group. But some exceptions are there. If we consider halogen series, what is our halogen series? If we consider fluorine, chlorine, bromine, iodine, astatine, these are our halogen series. Fluorine, chlorine, bromine, iodine, astatine. As per rule, what we already discussed, that electron affinity decrease down a group. Electron affinity decrease down a group. For that, electron affinity of fluorine should be higher in comparison to chlorine. Electron affinity of fluorine should be higher in comparison to chlorine. But when we see the value of electron affinity, then what we see, the electron affinity of chlorine is higher in comparison to fluorine. Here we will get an exception. What is the cause behind it? If we consider fluorine, then what is the electronic configuration? 2, 7. If it is the nucleus, this is our first cell and this is our second cell. There are 2 electrons in the first one and 7 electrons in the second one. As a result, what we will see, the size is very small. Here only 2 number of cells are present. As a result, the size is very small, and due to this very small size, in this second cell, in this second one, the number of electrons are much higher. As a result, there are already electron repulsion present, and due to this electron repulsion in our second one, it will be little bit change their property. It will be little bit less affinity to take electron in its outermost shell. It will be little bit reluctant to take electron in its outermost shell. As a result, the electron affinity is less. Whereas the size of chlorine is much higher. For that, the electron affinity will be higher. Today is up to this, and we will discuss the next part in the next class. Be serious, note all these things, and take care about your studies. Okay, thanks a lot.